In example 8, we are going to do some combinations of operations. So a problem might involve like both addition and multiplication or subtraction, and it might have an exponent on it. So we're going to try some of that. The thing you need to keep in mind is what's written in the top. Please follow the usual order of operations, which is PEMDAS, when applying matrix operations. Okay, so if you remember PEMDAS, and I'll write it at the top here, okay? The P stands for parentheses, okay? So if you see something in parentheses, you want to do that first, okay? Then you've got the E, okay? That is for exponents, okay? So you want to do that next. So you might see like an example of that. You might see a matrix A squared, okay? So that's an example of an exponent. It's a power. You want to do that next. All right, then you usually, if you're working with just numbers, you would do multiplication and division together from left to right. If you notice, or I don't know if you've thought about it, we haven't talked about matrix division, okay? There is something that's kind of matrix division, but it's not what you think. So we're going to disregard division here. So we're just going to say multiplication comes next. Okay, so 3, you would do the multiplication. Okay, and then as far as numbers go, you do addition and subtraction together from left to right. Okay, so the same thing will happen here. You do addition and subtraction together from left to right. Okay, so remember what that means. If you had matrix A minus matrix B plus matrix C, okay, so where you had both addition and subtraction involved, you would do addition and subtraction together from left to right. So if you're moving from left to right, you do the subtraction first. So you would do A minus B, get that result, and then add the C, okay? Don't think that because addition is listed first in PEMDAS that you need to do the addition first and then do the subtraction. Addition and subtraction are done together from left to right, both for just numbers and for matrices, okay? So we are going to follow the usual order of operations. All right, in example 8, we are going to refer to the following matrices throughout this problem, A, B, C, and D of varying sizes, okay? So we're going to perform the indicated operations if possible, because remember, you've got to follow the rules for adding and subtracting and for multiplication as far as if you can do those operations. All right, in example A, all right, we're going to do in parentheses B transpose minus I times A. Remember, the T, sometimes it's written as a lowercase t, sometimes it's written as a capital T. But if you see B transpose or something raised, it looks like it's something raised to the T power, that's transpose. So don't forget about transpose, okay? So in parentheses, we're going to do B transpose minus I. Remember, I is reserved for the identity matrix. When you look at these matrices up here, there's no I listed. You've got to remember that I means identity, okay? And then we're going to take that and multiply by A, okay? According to the order of operations, we need to do what's in parentheses first, okay? So let's go ahead and do, let's go right here and let's do B, I'll use a capital T, B transpose minus I, okay? So let's look at B, here it is, okay? We're gonna do the transpose, so remember how that works. The first row is going to become the first column, okay? And then the second row is going to become the second column, okay? So that is B transpose right there, okay? Then we have to subtract the identity. And remember, the identity can come in different sizes. And they don't tell you here. You're not told to use I2 or I3 or I4. You're not told. And the reason is because you should know, okay? Remember, you are subtracting these two matrices. In order to subtract, they have to be the same size. Okay, so since this guy is a 2 by 2, you're going to need the 2 by 2 identity matrix. Okay, so that's what you would write down. Okay, so now we're able to subtract the matrices because they're both the same size, and we're going to subtract corresponding elements. Okay, -3 minus 1 is -4. Okay, 2 minus 0 is 2. and then 1 minus 0 is 1, 5 minus 1 is 4, okay? So that's the quantity B transpose minus I, okay? So once you have that, you've got to multiply that result by A. Now, remember, matrix multiplication, the order matters. B transpose minus I, that result has to go on the left. Okay, so you're going to put that first. Absolutely necessary that it goes on the left. Okay, so take B transpose minus I, and now we're going to multiply that by A. Okay, so go up here and grab the A matrix. And we're going to try to multiply these guys together. Okay, and then we'll be done. All right, so let's check out to see if we can even do this. Okay, this is a 2 by 2. This is a 2 by 3. Inner numbers match. Okay, the result will be a 2 by 3. Okay, so we're going to map out a 2 by 3 matrix. Okay, so we're going to need something that has 2 rows, 3 columns. So it's going to look like this. It's always hard to fit these things in. Okay, so here we go. All right, let's start here. This is the first row, first column. Okay, so we're gonna do our dot product. Okay, I'm just gonna underline here because if I highlight, I may end up writing or erasing the numbers here. Okay, let's do first row, first column. Okay, all right, so we're gonna do, let's see, it's gonna be -4 times 2. Okay, plus 2 times 0. Okay, that's what will go in that position. All right, next we've got the first row, second column. Okay, so this time we're doing the dot product still of the first row, but now we're looking at the second column, the -1 and the 4. Okay, all right, so let's write that down. Okay, so we're going to get -4 times -1 plus 2 times 4. All right, and lastly, for this row, we've got the first row, third column. So now we're doing the dot product of the first row, okay, first row, and the third column, okay? So we're gonna have -4 times 3 plus 2 times -2, okay? And we're done with the first row, okay? Moving on to the second row, this position is the second row, first column, okay? So now we're gonna have to change up what we're doing the dot product of, okay? So now we're doing the second row, first column, okay? So we're gonna do 1 times 2 plus 4 times 0. All right, and then now we're gonna do the second row, second column. Okay, so we are going to need the second row. Now we've got the second column instead. So this is going to be 1 times -1 plus 4 times 4. And then finally, we've got the second row, third column. Okay, so we need the dot product of the second row, but now the third column. Okay, so right here. So we will end up with 1 times 3 plus 4 times -2. Okay, and then we can simplify and we will have our answer. Okay, so let's do that. Okay, so this is going to be -8 plus 0, that's -8. All right, first row, second column, that's going to be -4 times -4, that's +4. +4 plus 8 is going to give you 12. Okay, and then -12 plus a -4, that's -16. Okay, bottom row, 2 plus 0, that's a 2. Second row, second column, that's -1 plus 16, that's going to be 15. And then lastly, we've got 3 plus a -8, that's going to be -5. Okay, here is your answer. Okay, this is B transpose minus the identity, all times matrix A.